Hi everyone. In this lecture, we will talk about quadratic equations. Uh, in our last class, or in our last lecture, we learned, or in the last couple of lectures, we learned about linear equation in one variable. But today, we will see a quadratic equation, or what quadratic equations are, and we will see different techniques or different methods to solve quadratic equations. So just to review what we did last time, when we say a linear equation in one variable, it has a standard form of the form ax plus b equals to c, or ax plus b, not c, just 0. Yeah. So if where a has to be different from 0. So if we have this kind of form, or if an equation has this form, we call it a linear equation in one variable. Now, what is a quadratic equation, or what does a quadratic equation looks like? Well, given that we have a, b, c, which are real numbers, if we have the form ax squared plus bx plus c equals to 0, remember we always need this equality in order to call this statement an equation. So in order this statement to be an equation, or to be called an equation, then we need that inequality, okay? So this form and the quadratic, we need this square here, okay? The first term of the x variable, the exponent of the first term has to be 2. Otherwise, it will be the same with this one. It will be linear, right? So this form, where a different from 0, is called the quadratic equation. A quadratic equation in the variable x. In this case, the variable is x. A, B, C, 3 of them, they are real numbers. They are given coefficients. Now, once we have such an equation, the next step, or the next question to be answered is, how do we solve those kind of equations? Or how many ways do we have? Or do we have only one way to solve them? Well, we have a couple of them. So let's go one by one. Now, before we go to looking at an example of how to solve a quadratic equation, let's look at this property. This is just property of two real numbers. So suppose you have two real numbers, m and n. Let's call them m and n. These are two real numbers, okay? Now, if you multiply these two numbers, and if the result is 0, if the product of these two numbers is 0, then we know that either m is 0 or n is 0. One of them or both of them, okay? Or if both of them are 0, still the product is 0. So for example, if n is 8 and n is 0, then the product of this is 0. If m is 0 and n is, let's say, 100, then the product is 0. Or here I will put, or both, okay? Or if both of them are 0, 0 times 0 again is 0. Therefore, this is what we call the zero product property. And we will use this property, or we will integrate this one when we solve a linear equation. We will use this property, okay? That's why we are starting with it. All right, now let's go to how to solve, or solving a quadratic equation. And we use the zero product property to solve this equation. Now, let's see how we can use the zero product property. Now, consider this example, this quadratic equation. We have 30x squared minus 130x equals to negative 40. Now, how do we solve this one? Now, the first thing that we need to do is always try to simplify these coefficients. As you can see, these are too huge. I mean, they are big numbers. So what we could do is like simplify them. Let's say, for example, can I factor out some part, right? That's what we need to ask, because it's much more easier to work with numbers between 0 and 10 or maybe a bit bigger than working with such kind of numbers greater than 100. Okay, so can we factor out part of it? Do they have common factor? Well, they do. At least I can see a 10, because 30 can divide a 10 without remainder. 130 can divide 10 without remainder, and this can divide 10, right? So that's one way. Another way is you could start with bringing this one to the left side and then factor out, right? So it doesn't matter which one you start with. So let me factor out. Okay, let me write the first step. Write in the form of x squared plus bx plus c equals to 0. Let's start with this one. Okay. So to write it this form, what we do is we add plus 40 on both sides. You add 40 on both sides and 40 on both sides. So negative 40 plus 40, this becomes 0. And we have a 40 plus 40 on the left side. So here I will have, 30x squared minus 130x plus 40. This 40 equals to, on the right side, I have 0. Now we factor out the common factor. So here we factor out this, or we divide, we multiply both sides by 1 over 10. So factorize this equation. Now, how do we factorize it? Okay, so we have this, and what I wanted to do is I wanted to write this one as a product of two binomial components or factors. And to do that is there are different ways, but for such kind of quadratic equation, let's call this one A, this one B, and this one C. So if you have something like this, and to find out the factors, what we do is we need to find two numbers. Let's call them M and N. Find N and N. And the criteria that these two numbers to fulfill is that M times N has to be the product of A times C, AC. A times C means these are our A and C. And M plus N has to be B, and B is this middle number. Okay, so in our case, M and N, we are trying to find these two numbers. A times C is 3 times 4, which is 12, and B is negative 13. Now let's try to find two numbers which satisfy this condition. Their product has to be 12, and their sum has to be negative 12, negative 13. And those two numbers, you can figure out this one. Those two numbers are negative 12 and negative 1, right? If you add these two numbers, sorry. Here I just put B, and this has to be A plus C, not just B, okay? So negative 12 plus negative 1 is negative 13, which is this one. And negative 12 times negative 1 is positive 12, which is this one. Therefore, the two numbers are this. One is M, one is N. It doesn't matter which one you call M, which one you call N. And then the next step is you break down the middle term based on the numbers that you found. So what I will do is 3x squared minus 12x. I'm breaking this down into two parts based on that, minus x This is minus 1x because we have that 1 plus 4 equals to 0. Now you factorize this one. You take the common factor from these two, just pair. So from this one, from the first group, the common factor is 3x, and the remaining part is just x minus, from here, the remaining is 4, because if you distribute this one, you get this. Minus from this one, the common factor is negative 1, and then we have positive x and minus 4, which is 0. And then from here, as you can see, we have two factors again. We have two groups. This is one group, and this is another group, right? Group 1 and group 2. So from these two groups, from group 1, from this first term and second term, do they have a common factor? Well, yes, they do have common term, which is x plus minus 4. And then from here, the remaining is 3x, and from here, the remaining is negative 1, and we have the two terms. So this equation up here is the product of these two terms. Now, this is the point that we apply the zero product property, right? So we apply the zero product property. And how do we apply it? Well, I have now here, I have this number times this number equals to 0. You remember, when you have m times n equals to 0, either m is 0 or n is 0 or both are 0, okay? And we do the same thing. Now, if these two are 0, if x minus 4 and 3x minus 1 are 0, then this means either x minus 4 has to be 0 or 3x minus 1 has to be 0. One of them, or both of them, doesn't matter. And now we solve this one because these are linear equations now, okay? We don't need parentheses here. So from here, we add 4 on both sides. If you get this one, you don't need to add this. I mean, you don't show this one because you can just transfer it to the next if you are comfortable with it. So this is just x is equal to 4, or here we have 3x. You add 1 on both sides, and then you have 3x equals to 1, and then multiply both sides by 1/3. And here they cancel out, and you have x equals to 1/3. So from the second term, we have x equals to 1/3. Therefore, the solution to this is solution set is 4 and 1/3. Okay. Now, remember, always we need to check these answers or both of them in the original equation. So we have to always remember to check whatever we get in this original equation. Okay. And then we have another property that we need to study and that we will be using in the next technique. And that's the so-called square root property. Okay, this is the second property that we are studying now. And this property is if you have x squared equals to k, then x equals to plus or minus root k. And we write the solution set as curly bracket root x minus comma negative root x, or in short, we write it this way. So for example, if you have x squared equals to 4, then x is plus or minus root 4, and we know root 4 is 2, so this is plus or minus 2. Therefore, the solution set is -2. They are -2 and +2. Or in short, we write it ±2. So this is always, I mean, the solution to this one is always ±2. Because if you plug -2 here, then this becomes true, because -2 squared is 4. If you plug 2 in here, then 2 squared is 4. Again, it makes it true. That's why we get ±2. Now we use this property again in solving a quadratic equation. And let's see how we can use this square root property. Now consider these two examples. Now the first one is 2c squared plus 80. Okay, so for this kind of thing, because we don't have the middle term, if you remember, we have a middle term, which is b squared bx. Okay, so we don't have that one. In this case, we have the square term, the first term, and the constant term. So for this one, what we do is just isolate this on one side and take this one on the other side. So to take this one to the right side, we just subtract 80 on both sides. Okay, so these guys, they cancel out. Positive 80 minus 80 becomes 0, and on the left, on the right side, we have negative 80. So this becomes, and again, multiply by some number so that this can be this can be 1, and that some number has to be reciprocal of that number. And I do the same thing on the right side. So this, they cancel out. We have c squared, and simplify this one. We have this. And then now take the square root on both sides. We'll just apply the square root property. Apply the square root property. So c has to be plus or minus root -40. Now, luckily, we learned this imaginary or complex numbers. As you can see, we have negative number inside the square root. And now we don't have to worry about it since we know what this means. And we can simplify this one further. And this is plus or minus square root of -40 is square root of 40 times I. This is what we learned in the last lecture. And again, I can simplify this one further. I will go continue plus or minus. 40 is 4 times 10. So we have root 4 times root 10 I. And we can find the root of this one. Therefore, this is plus or minus 2, because this is perfect square. And square root of 10 as it is. And we have the I. Therefore, the solution to this one, oops, I have to put this on this side. Right. Okay, so solution set to this one is plus or minus 2 root 10 I. We have two solutions. And for the second one, here we have a term here. Okay, and we just apply the what you call the square root property for this one. Okay, because we have the constant term on the right side and we have this on the left side, and there is a square here. Okay, so what I do is we have, if this is the case, then using apply by applying this, we get t plus 4 equals to plus or minus root 24, right? And then we can simplify this one further. So I will isolate this constant, this variable. So we have to subtract 4 on both sides. So this becomes t, and we have -4. We'll write it first, and then we have plus or minus. And what is this? 24 is 4 times 6, so we have 2 root 6. Now, for this one, the two numbers are -4 plus 2 root 6, or -4 minus 2 root 6. I will write it separately now, just for you to see it. And instead of writing plus or minus, I will put it this way. But still, there is no problem with, it's not wrong, even if you write it plus or minus. This is one number, and the second number is, you just change this sign, and well, you have two numbers. Okay, so these are the solution set to, or this is the solution set to this equation. So this is how we apply the square root property. All right, and then again, there is another way, or there is another technique, or another property, I would say, and that's complete the square. I forgot TE, complete the square. And what is completing square, or complete the square? What does that mean? Well, this is the process of creating a perfect square trinomial. What we mean, or what I mean by this is, if you have such kind of thing, if you have a variable, a quadratic statement like this one, then in order this one to be a perfect square trinomial is, if you have this, then you can write this one as x plus some term here, the whole square. So that's what we mean by perfect square. Can you write this one in this form? Can you factorize it and write this one in this form? If you can write this one in this form, then that's what we call the perfect square trinomial. Trinomial means there are 3 terms, 1, 2, 3. This is trinomial. Okay. Now, if you have this expression, x squared plus bx plus c, and in order this one to be a perfect square trinomial, the property that we need, well, there is one thing. This coefficient of the first term has to be 1. That's what we're talking about, is when the coefficient of x squared is 1. If it is 2 or more, or I mean, if it's different than 1, then there is, we have to simplify it so that it becomes 1. Okay, we have to do something. All right, so assuming the first coefficient is 1, or the coefficient of x squared is 1, then we have here b times x and plus c. Now, in order this one to be perfect square trinomial, or in order to call it perfect square trinomial, c has to be, this term has to be half of b squared. If that's the case, then this is perfect trinomial. Okay, now let's see. Now, by completing the square means making this trinomial satisfy this condition. Okay, c becomes half of square of half of b. Let's say we have this. Now let's find c, so that this trinomial becomes perfect trinomial, perfect square trinomial. So we don't have any number here. I just added this c so that we can fill it up. Okay, so we have these two numbers. What do I need to put here in place of c so that the whole term could be perfect square trinomial? Well, this is the property now. We know c has to be half of b squared. And this is half of b, in this case is 12. And, well, the whole square, not only that one. And half of 12 is 6, so 6 squared. And this is 36. Okay. Therefore, this is x squared plus 12x plus 36. So this is perfect square trinomial. Okay, now we made it perfect square trinomial. And let's go to this one. We have x squared plus 5x plus c. And in order to make this one perfect square trinomial, c has to be half of our b, in this case is 5. So 5 the whole square. And half of 5, or 5 over 2, is just 5 over 2 squared. And this is 25 over 4. Therefore, the equation, the trinomial becomes x squared plus 5x plus 25 over 4. And for this one again, let me use c instead of and. And for this one again, c is half of, in this case, our b is all this. Do not forget the negative term. Okay, so this is negative 2 over 2 times negative 2 over 3. Sorry, negative 2 over 3 squared. Now, if you simplify this one, there's 2, they will cancel out. So we have negative 1/3 squared, and that's 1 over 9. Therefore, x squared minus 2/3 x plus 1 over 9 is a perfect trinomial. Okay, so this is how we complete a square. By completing square means finding c, so that the whole thing becomes a perfect trinomial. And we have seen these 3 examples how to make a trinomial perfect square. Now, we use this completing square technique to solve a quadratic equation. And of course, we combine it with the square root property and the zero product property. Now, suppose we have this equation, this quadratic equation, and to find this one, we need, okay, so the first step is, let me see. The first step is write the equation in the form of ax squared plus bx plus c equals to 0. Now, how do we write this one in this form? Well, this is, we need to bring this one on the left side. Therefore, this becomes x squared minus 8x. We just subtract 8x on both sides. Minus 2 equals to 0. Okay. And then we isolate this, or we move this constant. Let me change. To the other side. So we move this to the other side, and then we have x squared minus 8x plus something equals to positive 2. Okay, so I move this one, and I need some number here. I need some number here so that this term becomes perfect square, because in this case, this is not a perfect square. We know that, right? This is not a perfect square, even though it's a trinomial. So I move this one to the right side. I move this to the right side so that I can complete this one to make it a perfect square. All right. So now how do we find this number? Well, we know this number is the square of half of this one. And the square of half of this one is, half of this is -4, because there is a negative here. Half of this is -4. -4 squared is 16. Therefore, we put x squared minus 8x plus 16 equals to 2 plus, do not forget to add it on the right side as well. So we add the 16 on both sides. Once we found the number that we need to add so that this can be a perfect square, then we add it on both sides. The reason why we add it on both sides is because we don't want to change the whole equation, okay? But if I add it only on the left side, then this is not going to be the original equation, okay? This is totally a new equation. Okay, now we simplify this. Now we have this, so just simplify it. Let me put this. Complete the square. And then the next step is let me see. So here we have x squared minus 8x. And this term, we need to factorize this one. So because we are saying this is a perfect square, so this is what we call, it's going to be x minus 4 the whole square. This -4 is half of this. Okay, since this is a perfect square, just take the half of this number, put it like this, and it becomes like this. And then on the right side, we have 18. Now here, we apply the square root property. And then solve for x. So here we have x minus 4 squared equals to 18. And then x minus 4 has to be plus or minus root 18. And x has to be, we add 4 on both sides. So we move this one to the right side. And it becomes 4 plus or minus. And this one, we simplify it. This is 9 times 2. We have root 18 equals to root 9 times 2. And this is root 9 times root 2. This is perfect square, so it's 3 root 2. So we have 3 root 2. Therefore, the solution set to this one, of course, we have to check it. Solution set to this is 4 plus or minus 3 root 2. Okay, so this is how we complete the square and then apply the square root property to solve a quadratic equation. Okay, and another example, we have another example here. In this case, as you can notice, the coefficient of the quadratic or the second power, the first term, is not 1. So I have to make sure this coefficient is 1. Okay. All right. So first we write it in the form of x plus bx plus c equals to 0, and that's in that form. And then we divide all by this number so that this coefficient becomes 1. So step 1, divide by -3, which is this number, or multiplied by 1 over negative 1 over 3. So we have -3x squared plus 5x minus 7 equals to 0. And this is just x squared minus 5 over 3x plus 7 over 3 equals to 0. Okay. And now we have this one. And after this, what we do is we move this one to the right side so that we have x squared minus 5 over 3x plus some number here equals to negative 7 over 3. Okay, so we add some number here so that this becomes a perfect trinomial. And we add the same number that we add on the left side on this side as well. Okay, we add that number here. And what is that number? Well, that number is half of this number squared, right? So half of negative 5 over 3 times 1/2 is negative 5 over 6. And square this one, positive 25 over 36. So this number is this one. Therefore, I have x squared minus 5 over 3x plus 25 over 36 plus 25 over 36. And on this side, we have negative 7 over 3. Okay. So the left side, now I can write this one as a perfect square. This is x minus 5 over 3 squared. This one. 5 over 6. Not 3. This is 5 over 6. Half of this one, half of this number, equals to, and we have to simplify this. So this is 12. Yes, 12 times 7. 484. X minus 5 over 6 equals to, so what is this? This is 9 negative 59, I guess, over 36. I think if I'm right, it is this one. You can use calculator. Well, not actually. I don't advise you to use calculator, but just you can take your time and assess it. So this is x minus 5 over 6 equals to square root of negative 59 over 36. Now here we are applying the square root product now, because we have this step, and then the next is applying the square root product. So we have this one. And x, we move this one to the right side, plus, this is plus or minus, plus or minus. Here I have negative 59, so this is square root of 59 over 36 I, because we have negative inside, so we have to take out the I. Now we make the inside a positive number, and if it's possible, we simplify it further. If not, we just leave it that way. But this one we can simplify it a little bit, and the square root of the denominator is 6. The numerator is not perfect square, so we have square root of 59 over 6 I. Therefore, the solution to this one becomes 5 over 6 plus or minus over 6 I. Okay. All right. And there is one more technique that we use to solve a quadratic equation, and this is so-called quadratic formula. So each of the 3 techniques that we've seen, they all are used for different cases, different scenarios. Okay, so if we have a different type of quadratic equation in different form, then we can use one of the techniques. Of course, you can pick, there is no right or wrong. You can use any of those as long as you can. Just make sure that you can be flexible with that. So you have to be, you have to choose which one is best for the equation given. Okay. Now this is more general. This quadratic formula can be used for any type of, for any kind of equation. Not any kind of equation, but any kind of quadratic equation. As long as it's a quadratic equation, you can use this formula to solve the for the value of x or the solution set. Okay. So if you have a quadratic equation in the form of this, ax squared plus bx plus c, where a is different from 0, then the solutions are given by this. Negative b is the middle number, plus or minus square root of b squared minus 4ac plus over 2a. Okay, so here we are, all of them, they are positive. We have plus plus. Okay, but they could be negative, so you have to be careful here. So let's say if you have here negative 3x, let's say in the middle term, if it's negative 3x, our b is not only 3 but it's negative 3. Okay, therefore here negative 3, this is b, this negative is this negative, so it becomes 3. You will have here positive 3. So we have to be careful on that. Okay, now let's try to use this equation, this method to find the solution set of these quadratic equations. Now here we have this equation. Well, is it a quadratic equation first? Well, here it doesn't look like it is a quadratic equation, but definitely it's a quadratic equation, because when you multiply this two, you get a quadratic equation. And that's what we need to do. We distribute this one, and that becomes x squared, this times this, and this times this becomes negative 8x equals to 3. And now we have to write it in the form of ax squared plus bx plus c equals to 0. Okay, so that we can apply the formula. And in that form, it becomes x squared minus 8x minus 3 equals to 0. Now, what is our a? Our a is 1, our b is negative 8, and our c is negative 3. Okay, and that becomes, so using the general formula, x is negative b plus or minus square root of b squared minus 4ac over 2a. Now just plug in the numbers. Negative b is negative 8 plus or minus negative 8 squared minus 4 times 1 times negative 3 over 2 times 1. And this is positive 8, this term, plus or minus, this is 64. 4 times negative 3 is positive 12, and the denominator is just 2. Okay, again, we simplify this one, and here what do we have? This is 76, right, over 2. What is 76? 38, 19. I think this is 8 plus or minus. I guess 76 is 4 times 19. Let's see, 36. Yeah, 4 times 19. Therefore, this is 2 root 19 over 2. And you simplify this one, you simplify this. This is 4 plus or minus root 19. Okay. Therefore, the solution to this one is 4 plus or minus root 19. Okay. So as you can see, this is much more easier, of course. And the good thing is you can use it whether it's the coefficient is 1, the coefficient of the first term is 1 or not, it doesn't matter. You can always use this quadratic equation, quadratic formula. And then we have this, which a bit looks like more complicated. And for such kind of equations, what you need to do first is you have to eliminate these fractions. And to eliminate this fraction, we have to multiply all the sides by the common LCD. And in this case, the LCD is 12, because 12, we have 12 that can divide 12 without remainder, and that can divide 2 without remainder, and divides 4 without remainder. So multiply all by 12. 5 over 12x squared minus 1 over 2x plus 1 over 4 equals to 0. And of course, we multiply this one by 12 as well, because in this case it's 0, it doesn't make any difference, but in general it's a good idea to have that, or to understand what we are doing. Okay, it doesn't make any difference whether you multiply it here or not here, because you have 0 here. Now here we distribute this one. 12 times the first term, we simplify it, we get 5x squared. 12 times the second term, it will be 6x, because 12 divided by 2. And 12 times the last term is just 3 equals to 0. And as you can see now, this one is a quadratic equation, which is written in the form of ax squared plus bx plus c. And here our a is 5, our b is -6, and c is +3. Therefore, we have x, not square, just x equals to -b, which is -6, plus or minus -6 squared minus 4 times a is 5 and c is 3 over 2 times 5. All right, so this is 6 plus or minus, this is 36 minus, this is 2060 over 10. So we have 6 plus or minus, this is 24, -24 over 10. And again, you have here an imaginary number, because we have negative number inside the square root. Therefore, we have to handle that one, and that's root 24i over 10. And we can simplify this one further. Root 24 is 4 times 6, so this is 2 root 6i over 10. And I can write this one a bit differently, and that will be, split this one into 2, and that will be 3 over 5 plus or minus root 6 over 5i. Therefore, the solution set to this one becomes 3 over 5 plus or minus root 6 over 5i. Okay, so this is the solution set to this equation. All right, so the next thing is, there is one important thing that we need to learn here, as a concept. So as you can see in this general formula, quadratic formula, we have a term inside the square root. We have this b squared minus 4ac. And that b squared minus 4ac, we call it discriminant. Okay, and we use this discriminant to determine what type of solutions we have before we solve the equation. Just by looking at b squared minus 4ac, we can figure out whether we will have one solution, two solutions, or if both solutions are real numbers or non-real numbers. Okay. Now, for example, if b squared minus 4ac is negative, then we will have two non-real, which means imaginary or complex numbers. We will have two non-real solutions. For example, if you have 2x squared minus 3x plus 5 equals to 0, then b squared minus 4ac will be 9 minus 4 times 2 times 5. And this is 9 minus, this is 20, 40, and this is negative 31, which is less than 0. Okay, and if you solve this equation, you will get x equals to 3 plus or minus root 31, negative 31 over 4, which is 3 plus or minus root 31 over 4i. And as you can see, we have two non-real solutions. One is 3 over 4 plus this term, and the other one is 3 over 4 minus this term. And as you can see, when you have I, it's not a real number anymore, okay? And then the other case is if b squared minus 4ac is 0. And if this happens, then we have only one real number, okay, if this term is 0. And in this case, for example, you have b squared 36 minus 4 times 9. This is 36 minus 36, 0. And using the quadratic formula, the solution becomes minus b, which is negative 6, plus or minus root 4a, b squared minus 4ac. B squared minus 4ac is 0 over 2 times a is just 2. And now since this is 0, we just have negative 6 over 2, which is negative 3. And as you can see, the solution to this one is just one real number, which is negative 3. And the last case is when b squared minus 4ac is greater than 0. And in this case, we have two real solutions, okay? And here, for example, b squared minus 4ac is 49, 49 minus 4 times 2 times negative 1. And it is 49 minus, this is 8. So we have 57, which is positive, okay? And the solution to this equation becomes negative 7 plus or minus root 57 over 2 times a is 4. So we have negative 7 plus or minus over 4 plus or minus root 57 over 4. Now here we have two real numbers. One is negative 7 over 4 plus root 57 over 4, and the other is negative 7 over 4 minus root 57 over 4. Okay. All right. So this is all for today, and I hope all the techniques that we've seen makes sense. And make sure you understand all of them. And well, unless it's unless it's specified, when you solve a quadratic equation, just try to figure out which technique is best for you. Okay. If it's specified, then of course you have to use that technique. Otherwise, you can use any of the techniques that we have learned. Okay. You can use the quadratic formula. You can use the square root method, and any of those. Okay. All right. So see you in the next class.